Hey, I'm going to go through some exponent rules with you. Maybe you've seen them before, maybe you haven't, maybe you've forgotten them. So I'm going to review them with you. So if you multiply x to the fifth times x cubed, the bases are the same. So I just wanted to show you what that looks like with repeated multiplication. X to the fifth would look like this, 5x's being multiplied together. X cubed would look like this. So 3x's multiplied together. What you really have is x to the eighth power, if you count up all those x's. So the rule is if you have the same base, you're allowed to add together n plus m. So 5 plus 3 is x to the eighth. The quotient rule is kind of the same. When we write out repeated multiplication, we'd write x to the fourth over x cubed. If I cancel the x's that I can cancel, see how I just end up with x in the numerator? So that's x to the first power, or just x. So the rule is you can actually take the number of the power in the numerator and subtract what you have in the denominator. So n minus m. The power rule, if I write this out as repeated multiplication, it's x squared times x squared times x squared. That's what x squared cubed means. So if I write that out again, x times x times x times x times x times x, I just wrote out 6 x's. So I really have x to the sixth. So what is the actual rule? You can take n and multiply by m. So there's also a distributive power rule for both products and quotients. So when you've got a power outside the parentheses, you want to make sure that you distribute it to both of the terms inside the parenthesis, a to the n and b to the n. Just like if it's a quotient, a to the n over b to the n. So you're making sure to distribute your n inside the parentheses. So let's do one of these for an example. When you take this squared, you have to make sure that you're going to square the 3 and square the x cubed. And squaring the x cubed would make it x to the sixth. So I'd actually have 9x to the sixth at the end. And here I'm going to distribute this power of 3 inside the parentheses. So I'm going to have x to the sixth on top and y to the 12th on the bottom. Those bases are different, so I can't take this any further. So I'm going to leave it as x to the sixth over y to the 12th. The negative exponent rule. So all the negative exponent rule does is it takes the reciprocal of what you started with. So you don't want to have negative exponents. If your exponent is negative, what I think of is it's not happy where it is. So this is currently a to the negative nth power over 1. You're going to move the a to the nth down to the denominator. Likewise, if you start with a negative exponent in the denominator, you could move that up to the numerator and make it a positive exponent. So why is that? So let's just look at, what if we had a cubed over a to the fourth and we used that repeated addition again to represent this problem? So 3 of our a's would cancel, right? A cubed over a to the fourth. 3 of our a's cancel. And I'm left with 1 over a. What if I use that quotient rule? I take 3 and subtract 4. Isn't that the negative first power? So we've got that 1 over a and a to the negative first power are equivalent, which is basically the negative exponent rule. So if I've got these terms, 45 to the negative first power, that's 1 over 45 to the first power. If I have x to the negative second power, that's 1 over x to the positive second power. So you're moving it and making the exponent positive. And the last rule that we're reviewing today is the zero exponent rule. Anything to the 0 power is always 1. So why is that? Well, let's look again at repeated multiplication and canceling. So a cubed divided by a cubed, cancel, cancel, cancel. Anything divided by itself is 1. So what if we use that quotient rule and we take 3 and subtract 3? Isn't 3 minus 3 0? So this is really a to the 0 power. So isn't a to the 0 power and 1, don't they have to be equivalent? So in this example, just 12 to the 0 power is 1. You could try it on your calculator. 12 to the 0 power is 1. And the distributive property, right? You'd have x to the 0 power, y to the 0 power, which is 1 times 1. I don't even have to do that step of distributing. Because the whole parenthesis is raised to the 0 power, it's going to give me an answer of 1. So now you've got these rules written down for you. So you might have to go back and review them because I did that pretty quickly. So you've got this kind of as your exponent rule cheat sheet. You are now going to complete 1 through 18 to really practice these exponent rules. Try to go through them slowly to get each one right. Don't go too fast. Keep your work organized, and you're going to submit this page through Google Classroom.